So we have v plus I w equals 5, I plus 2I v, v minus w equals 3I. So this is just like simultaneous equations in two variables as usual. We can solve by substitution or elimination. So here we are using elimination. This is the original equation. So we want to eliminate w here. So we multiply both sides of this equation by I. So we multiply throughout by I. We get IV I squared w 5I. I squared is minus 1, so actually it's minus w. So now we can subtract, we can cancel out. On the left we have I minus 1 plus 2I, so that is a minus 1 minus I. And here we subtract 5 minus 3, that's 2, so we have 2I, and we divide both sides by the brackets here, so we have 2I divided by minus 1 minus I. So now we want to realize the denominator, like rationalizing denominator, but now we are realizing because we want it to be real, free of I, imaginary. So we multiply by the complex conjugate of this minus 1 minus I, which is minus 1 plus I. So when we multiply 2I times minus 1 minus 2I, 2I times I, 2I squared, and minus 1 times minus 1, just 1, minus 1 times I, minus 1 times minus I times plus I, and remember I squared is minus 1, so this is actually minus 2, and this is actually plus 1. 1 plus 1 is 2, so we divide by 2, we get minus 1 minus I, the final answer for v. After we find v, we use one of the equations, use a simpler one. We replace the v with minus 1 minus I, and then we solve for w. So here we add 1 plus I to both sides. So 5 plus 1 is 6 plus I. So now we multiply both parts by minus I. Okay, in case you are wondering why, well, because after we multiply we get minus I squared, which is 1, because minus I squared is minus 1, so minus 1 is positive 1. We have only w on the left. On the right, 6 times minus I minus 6I, I times minus I minus I squared. Again, I squared is minus 1, so we have plus 1 here. So 1 minus 6I is the final answer for w. And now the locus, we have the absolute value of z only on one side. This is a circle, and to identify the center of the circle we use z minus z1 form. So z minus this, and if you open up the brackets, minus 2 minus 3I, you should get exactly the same. And the center is therefore 2, 3, the radius is 1, and equals means we only use the circumference. So label the center of the circle, make sure the radius is 1, we get the final answer. Now the least value of the argument of z. So the z is actually the line from the origin to the circumference, to any point on the circumference of the circle. Now because we need to find the least argument, we want this angle theta to be as small as possible. That is when the point is at this tangent point of contact here. So this is a tangent line, that's why it's perpendicular. We need to find the angle theta. Now if you look at the triangle, this triangle here, so this is a right angle triangle, this is a triangle. We know that this length is 3, this length is 2. We can find the angle, we're gonna call it beta. We can use inverse tangent, we can find the angle beta. And if you want to find the hypotenuse, of course we use Pythagoras. Square root of 3 squared plus 2 squared, we get root 13 for the hypotenuse, this line here. Now that we know this hypotenuse, look at this triangle. So this triangle is this triangle here. The hypotenuse is this root 13, and we know that this is the radius is 1, and we can use sine. So the alpha is actually inverse sine. Opposite over hypotenuse 1 over root 13, we can find the alpha. Now that we have the beta and the alpha, theta is actually this beta angle, this beta, minus this angle alpha. So that's theta, and we use a calculator, we get the final answer. Alright, I'll see you again.